Hello everyone and welcome back to That Engineering Girl. For those of you who don't know me, my name is Ruha and I'm on a journey engineering my life both figuratively and literally, and that is because I have just finished my third year of electrical engineering with a minor in computer engineering, and I'm currently on my 16th month internship as an embedded software developer. So the question today is, what are we talking about, Ruha? Well, there is one question that every engineer gets asked when they go out into the real world after graduating and they start working. And that question is, how much of your degree do you actually use? Now, I know this from a personal experience because every single engineer that I talk to in an informational, and wow, that's loud. I'm gonna shut my window really quickly. Okay, I'm back. Hopefully that's better. Window is closed now. So, I know this from a personal experience because every single engineer that I talked to in an informational interview, I always asked, how much of your degree do you actually use? Now, since I'm on my internship and I've had the privilege of being in a degree and then transitioning into a workplace, I thought, you know what? It's time to give back, Ruha. It's time to answer the question for myself. How much of my degree am I actually using at my internship? And that is what we're going to be talking about today. So, without further ado, here are the 5 things that I learned at university during my engineering degree that I'm actually using at my embedded software developer internship. Alright, so we changed angles a little bit because I have my laptop here, as always, as my left hand something, because it's definitely not a man, as the idiom, I think it's called, goes. But anywho, so the very first thing that I learned during my engineering degree that I use extensively, and I cannot stress that word enough, extensively at my internship, is documentation. Now, this is so important that I was actually asked in my interview the experience I have with writing and creating documentation. And I actually learned this in school during my third year design course because this is something that my professor really stressed, and he literally said to me that this course is an excuse for you guys to produce documentation because it's so important in industry. And I kid you not, I completely agree with that now. Some of the documentation that we produced in the course is requirements specifications documentation, design review documentation, project plan, minimal viable product, design specifications, acceptance test plan, and then of course we had our final presentation. Now, during my internship right now, I am heavily producing documentation. Nothing at my internship gets done without documentation. Like, no one's work gets done without documentation. You need documentation for everything. Now, some of the documentation that I've produced at work includes a project plan, an ICD, which is an interface control document. I'm also working on an acceptance test plan, a software system design. There's going to be an acceptance test report, and many other documents. So this is something that I learned at university that has saved me at my current internship and will probably stay with me for the rest of my life. So here's the project plan my team and I produced for the design course I mentioned. So there are sections like objective, scope, deliverables, organization, WBS, and a bunch of different things. It's a bit lengthy, but it's very close to the content that I have to include in the project plan I produced at work. Okay, so we switched angles one more time, hopefully for the last time, because as they say, third time's the charm. So let's get into the second thing that I learned during my engineering degree that I'm currently using at my software developer internship. Now, this is referred to as UART. Now, UART stands for Universal Asynchronous Receiver Transmitter. Now, I'll show what this looks like in a second, but what this refers to is essentially a communication protocol. It's just like USB, so it's a way for two devices to interact and communicate with each other. Now at work specifically, I use a UART to USB communication channel. I use this a lot. So let me show you what this looks like. So this is what UART is at a very high level from a schematic purpose. So you can see there's TX, RX lines. So this stands for transmitter, this stands for receiver. So one device is gonna transmit bits and the other device is gonna receive bits, and then vice versa. So I learned about UART during my embedded systems course, which I took last year during third year. And it was an introduction to embedded systems. I wasn't really into embedded systems then, but I actually quite like it now, especially since, of course, I'm doing an embedded systems internship. There's a reason for that. So I actually learned about UART during that course, and we used it for every single thing that we did in that course, pretty much. And so that's where I learned it, and I'm using it at my workplace now, actually. Okay, so the third thing that I learned during my engineering degree that I use at my internship is a high-level language like Java to create/edit a GUI. Now, GUI stands for Graphical User Interface, and it's pretty much everything at this point on your laptop. Everything is a GUI. Anything that has something that can take input from you as a user is a GUI. So I will show you what that looks like from a Java perspective, and somewhat like what I'm doing at work. I will show you that in a second. But what I mean by learning a high-level language like Java is last semester I took a software course in which I learned about Java and software development, and towards the end of the course actually the instructors quickly squeezed in creating forms with Java, so a GUI. And so that's what I'm referring to, that I already had exposure to using a language to create a GUI. And so when I had to do something similar at my internship, which is edit GUI code to add certain options to this GUI that we already had and were using, and I had to edit for my project, I was already somewhat familiar, like at a very, very high level familiar with what it would look like in the code. Like things like events and handling events and buttons and drop downs and, you know, clicks and presses and moving your mouse over certain things. I had familiarity with those ideas, and so when I had to go in and edit the GUI at work, I was able to quickly figure out how to do things and pick that up pretty efficiently, I would say. So at this point, let me show you what I'm talking about, because I'm sure you want some sort of visual. Okay, so this is a typical form that you can create with a language like Java. This is probably actually an example I think my instructors used in the course itself. And so then you have these, you can create pretty complex ones or pretty simple ones. Mine is actually, so what I mean by mine is the GUI that I'm using at work is actually written in C#. So it's a bit different in terms of graphical user interface. It has a few different features. Of course, I'm not able to speak about exactly what it does, but it is written in C# and it somewhat resembles what I'm showing you right here. All right, now the fourth thing that I learned that I'm using at my internship is lab equipment skills. What I mean by this is lab equipment like oscilloscopes, power supplies, multimeters. You know what I'm talking about if you're an electrical engineering student. All of your lab equipment, you need those skills. Like all the time. I'm specifically using a power supply right now, and which is not complicated. Oscilloscope is probably the most important thing you ever would need to know as an electrical engineer. I haven't gotten to the point where I need to use that yet, but I can almost guarantee that I will. So, lab skills I used at university or learned at university, I use extensively at my internship, and they have helped so much. Okay, so the fifth thing that I learned at university that I'm using at my internship is state charts. Now, this is something that I also learned during my embedded systems course last year, and that is how to create state charts and represent what's going on in your code at a high level. Now I'll show you what a state chart looks like, but it's exactly what I just said. It shows you the progression of your code and how it flows from a high level and what decisions are being made dependent on what variables or conditions. Now, this is much more sophisticated at work. What I'm going to show you right now is I would call a rudimentary version of what I'm doing at work, specifically because this was a beginner level embedded systems course and they just wanted to translate the ideas to us, not necessarily get us to be perfect at them. But I will show you one of the state charts my team and I made for that course. Okay, so this is one of the state charts my team and I built for my embedded systems course. This black box or black dot is what represents the start of the program, and then I'm sure you can follow through with the rest of it. But like I mentioned, this is a simple version, a very simple version of what I'm doing at work. And there you have it. Those are 5 things that I learned during my engineering degree that I actually use at my internship. Now, at a very high level, I'm probably only using 5% of what I've learned during my engineering major. So 5% of the technical things that I've learned during my engineering major. But there are so many other skills, non-tangible skills that you learn in an engineering major that have helped me everywhere. So do keep that in mind when I say I only use maybe 5% of what I've learned, because it is very unlikely that you will use every single thing that you learn during your degree. So I hope that gives you some of the ideas of what it's like in the real world and how you actually end up using your degree, specifically in a developer position, because if you're in another position, you're going to use other parts of your degree. So with that, I'm going to close off this video, and until next time.